topic in this class. Now we shall complete the topic first and we will move ahead with discussing of Bayes theorem. So we discussed here about the number of elements in a single set, in a particular single set only. Okay, let's discuss about number of elements in two sets, two particular sets. Okay, let me draw circles here. A set, A set, B set, and C set. Okay. So if we have to find out that how many number of elements are there in two sets, in let's say in A and B only, like number of elements in A and B only. So basically what we are talking about is this section. Nothing else than this. So it's simple. Number of elements in, sorry, I should not write this. Should write number of elements in A and B only. Only means only that those elements should be in these two sets only. So number of elements that are common in these both, excluding this area that is common in all three sets. This is the case. Okay. So similarly, we can write number of elements in B and C only by n of B intersection C minus n of A intersection B intersection C. And why this particularly is important for you in the probability chapter, I have also told you and stated that wherever there is n, you can replace it with what? Do you remember, Gurucharan? Okay. So these are the number of elements in A and C, B and C, and A and B. What if we have to write? What if we have to write number of elements exactly like in exactly two sets, in two sets, in exactly two of A, B, and C sets. Okay. So for these we can sum them all, right? So n A intersection B plus B intersection C plus A intersection C minus 3 times of n A intersection B intersection C. That is the formula for number of elements in exactly two of ABC sets. So now what we have written is, let me color it with pink. This, and this. this. This is the area that we are referring to here. Is that clear? Any doubt?
No, sir.
Let's now move ahead with the discussion of Bayes theorem. B apostrophe S, then theorem. Bayes theorem says when we have, like we discussed about dependent events, right? We have to, like, A event happened, then B event happened, and both of these events are dependent. So we had to find the collective probability earlier. So what we used to do, probability of A into probability of event B, given that A has happened. This is the probability of what? That A and B, both of them are happening, where A and B are dependent events. So similarly, we are going to discuss about dependent events, but not only in the set of two, more sets. For that, we require Bayes theorem. Okay, let's go by the definition. If an event A can occur only with one of the with one of n mutually exclusive events, mutually exclusive and also exhaustive events. Let them call B1, B2, B3, Bn. Okay. And the probabilities, probability of event A given that B1 has happened, probability of event A given that B2 has happened, similarly probability of event A given that Bn has happened are known. Probability of B1 event given that A1 has happened. Now actually it is like that an event A can occur only with one of n mutually exclusive hostile events. So it's like that you have n choices and you have to pick one choice, one choice, and then only event A can occur. Okay? So you have to first make a choice out of these n events, and that making that particular choice, we are calling that as an event. Event B1, B2, B3, Bn. You can only choose one at a time, and then you can go ahead with the event A. So now, if you have to find out that the probability of choosing B1 when event A has happened will be given by Bayes theorem. Okay, this is this is similar to the conditional probability, but you will be surprised to know here that how the formula will come out as in earlier conditional probability, probability of event B when A has happened, it was probability of A intersection B on probability of A. But this time, there are multiple cases, P1, P2, P3, Pn till Bn. So it's not that convenient for us to find out the probability of A intersection B1, B2, B3. That is why we are referring to this theorem. And this theorem says that the probability of B1 event, given that A has happened. Basically, it's like let's dwell upon the definition more, that event A can only occur with one of n mutually exclusive and exhaustive event. So event A will only occur when there is B1 happening or B2 happening or B1, B3, B3, B2, 3, B4 or Bn. These n events, one of these n events will happen, then only A can happen. So it would be apt to say that first we have to choose, or first there will be an event occurrence out of these n events, and then only A event can occur. So B1, B2, Bn, first one of these event will occur, then event A will occur. Okay. Now, if we have to find out that what is the probability of even B1 occurring when A has happened, we will give it by this formula. The formula is probability of, sorry, there is I here. Okay, probability of B even that we are talking about multiplied with B event that has happened. Sorry. Probability of event A occurrence when BI has happened divided by the same, though I will be taking its value from 1 to n and their summation. Okay, let us discuss. And I know this is not clear to you, but there is some picture that should be painted in your head. And when we will discuss the formula, it will be absolutely clear to you. So let's take that there are three events that can occur, and then A event can occur. So if you have to find out the probability of that B1 event has occurred for the occurrence of A event, then we will find out like that probability of A, okay, sorry. Uh, Probability of B1 into probability of A event, given that B1 has happened. Now this is like quite opposite of what we have to find out here. Divided by probability of B1 event into probability of A event occurring when B1 has happened, or probability of event B2, given that probability B2 has happened and then the probability of occurrence of event A. Similarly, probability of B3 event happening into the probability of A event happening, given that B3 has happened. So this is the formula. Let's rearrange the formula for the beauty of expression. Is there any doubt in understanding the formula?
No, sir. It's clear.
Okay, so let's discuss an example. Instead of me typing it, let me use the technology. Here's a question. Given three identical boxes, 1, 2, and 3. Okay, so let's make three boxes. B1, B2, and B3. Each each containing two coins. Okay. Both of the coins are gold coins. In box 1, both coins are gold coins. In box 2, both are silver coins. Okay, two gold, two silver coins. And there's a one gold and one silver coin, one gold and one silver coin in the box 3. A person chooses a box at random. Okay. So, for what is the probability of choosing a box 1? Is 1 out of 3 boxes. Same goes for probability of choosing the second. Same goes for the probability of choosing the third box, right? Do you agree that how we have finded out the probability of choosing any box? Yes, Guru. Hello, hello. Are you there?
Yes, sir.
Yes. Okay. Now let's read the question ahead. A person chooses a box at random and takes out a coin. Okay. If the coin is of gold, see, if the coin is of gold, it is given that the coin is of gold. What is the probability that the other coin in the box is also gold? So both of the coins will be of gold in a box when? In which box there are two gold coins? First,
First
second, or
B.
third?
First B.
First.
B1. B1. B1.
Sorry?
It's box 1, sir.
Yes. So we have to find out the probability that it is given that the coin is of gold. So first we have to name the event. Event of getting a gold coin as A. Let's call the event as A. So A has happened. What we have to tell? The probability of box B1. Okay. So if that is so, we'll first multiply the probability of event A happening and then probability of event A when B1 has taken place, divided by the probability of getting a gold coin via box 1 plus probability of getting a gold coin via box 2, probability of getting a gold coin via box 3. So if you like मोटा मोटी समझोगे तो This is the probability. This is the formula of probability of event only, where you have discussing about the favorable outcomes in the numerator and total possible outcomes in the denominator. This is both. These are two dependent events. That event A has happened and event A has happened through box 1. So this is what we are going to discuss. Okay? Is this clear that how this is
Yes, sir.
basically the formula of probability of any event in the numerator? We are discussing that a gold coin has been taken out, okay, into probability of that it has taken out via box P1. If we solve it further, then this is like just the formula of dependent events.
Yes, sir.
Yes, but there is a mistake. If this has to be equal to B1, like then we were discussing earlier, na, the formula of dependent events. कहाँ गया? Let me write it again. Probability of dependent events into these two has to be the same. Okay, and let's check in the Bayes theorem as well. Yes, these two were the same. I did a mistake in writing. Here there will be A only, but B1 here, B2 here, and B3 here. Okay, so this is the dependent event where A and B1 are dependent events. Okay, so we know probability of B1, B2, B3. What will the probability of getting a gold coin in B1 box? Okay, it is given that B1 box has chosen. So its formula is divided by choosing probability of B1 box. So we can also find out by this how many gold coin are there in B1 box. So 2 by probability of finding a gold coin in B1 box is 100%. Why 100%? How many favorable outcomes are there? 2. How many total outcomes are there? 2. Now let's discuss about the probability of B1. That is 1 by 3. 1 by 3 to 2 by 2. I guess we are doing some mistake. Probability of A conditional. Probability of A with this. So it should be probability of choosing B1 box. Okay, let's do it another way. Let's do by common sense. That we have to find out the probability of getting a gold coin in B1 box. It is simple that. So how many gold coins are there? 2. How many total coins are there? 2. So probability of getting a gold coin box B1 is 1. Okay. Now probability of getting a gold coin box B2 is how many gold coins are there? 0. How many total coins are there? Total 0 by 2. So 0 by 2 is 0. Probability of getting a gold coin in box 3. How many gold coins are there? 1. How many total coins are there? 2. Half. Is that clear?
Yes, sir.
Okay. So, and why particularly our formula was not working? Because we are not able to find out this. And that is precisely the reason we have written this in formula. Otherwise, if you would expand this, then probability of B1, into probability of A intersection B1 divided by probability of B1. So we will just simply write this only now. But that is the problem that we are not able to find out. That's why we have written this in this format. Is that clear? Is that clear or not?
Yes, sir.
Okay, let me rewrite everything in a better manner. Okay, so given there are three boxes, box B1, two gold coins, box B2 has one gold, one silver coin. Sorry. There are two silver coins. And box B3 has one gold and one silver coin. Now, event of choosing box B1, we are calling it as event B1 only. So its probability is 1 by 3. Probability of choosing box B2 is 1 by 3 also, because there are three total outcomes, and how many favorable outcomes for choosing B2 is 1 only. Similarly, choosing third box is also 1 by 3. Okay, this is all that is given to us. A person chooses a box at random and takes out a coin. If the coin, see, first the person has to choose the box and then takes out a coin. So taking out a coin, uh, and if the coin is turn out to be of gold, so let's call this event A, that has already happened. Okay. Now we have to find out that what is the probability that other coin is the box is also gold. When there will be two gold coins, when we'll choose box B1 only. So we have to basically find out the probability of box B1, and that there's a gold coin drawn out of the box. Okay. So for finding it, we'll write probability of B1 into probability of taking out a gold coin via a B1 box divided by probability of B1 into the probability of taking out a gold coin via the box 1, probability of choosing box 2 into the probability of taking out a gold coin via box 2, plus probability of choosing box 3 into the probability of getting a gold coin out of box 3. Okay. Is there any doubt till now? Any doubt?
No, sir.
Okay. So let's now find out choosing box B1 when a gold coin has been withdrawn. What is the probability of choosing box B1? That was 1 by 3 into what is the probability of getting a gold coin in box B1? So how many total favorable outcomes? There are two. How many total coins are there? There are two. And it would be better for us if we discuss here only. Probability of getting a gold coin in box B1 is total favorable outcomes 2, total possible outcomes 2. That is a 1. Probability of getting a gold coin in box B2 is how many favorable outcomes? 0. Total number of outcomes 2. So that becomes 0. Probability of getting a gold coin in box 3 is 1 favorable outcome, total 2 favorable outcome. Sorry, total 2 possible outcome. So the probability of getting a gold coin in box 3 is 1 by 2 only. So let's just put the values here. Is this clear? Is everything clear here? Yes or no?
Yes, sir.
Okay. So this was 1. divided by 1 by 3 into 1 plus probability of choosing box 2. This is also 1 by 3. Probability of getting a gold coin in box 2 was 0. Probability of choosing box 3 is 1 by 3. Multiplied with probability of getting a gold coin in box 3 was half. We can see there is 1 by 3 everywhere in all the terms. So we can just take common from 1 by 3 in the numerator and from the denominator, and they will cancel each other. Okay, what left? 1 upon 1 plus 0 plus half. 1 upon 1 point half is 1 plus half is 3 by 2. 1 by 3 by 2 is 2 by 3, which is our answer. This is an important question because it's the first example. And this is very good example for you to understand what is Bayes theorem and why it is required. I would like you to read this question and solution once again, feeling every step. And if you feel any doubt, you may ask. Please prompt me when you are done. Okay?
Okay, sir.
Done?
Yes, sir. No, yes, sir.
Hmm. Okay. So now tell me, what is the meaning of this? What is this finding out? Of which event? This is the this is the expression of conditional probability. This is the probability of event F when G event has taken place. Okay.
Okay, sir.
So now tell me, what is this?
Sure. A intersection B, sir.
So this is also saying that we are finding out the probability of event A and B occurring simultaneously. Okay.
Yes, sir.
I have a question here. Very interesting one. Gurucharan, do you like homeworks?
I do, sir.
You do.
Yes, sir.
Let me help you with this question. Then I'll give a single question to you as a home. Okay.
Okay.
Let me solve this question. And please listen to this question's explanation carefully so that you'll be able to solve the homework question.
Okay.
The question, an unbiased coin is tossed. Okay. If the result is head, so if a coin is tossed, there are two results can be head or tail. Okay. If the result is head, a pair of unbiased dice is rolled. Then two dices are rolled. Okay. And the number obtained by adding the numbers on the two faces is noted. ठीक है. If the result is a tail, a card from a well shuffled pack of 11 cards numbered from 2 to 12 is picked. Okay. So how many chances are there like a card is picked from 2 to 12? I should write legibly. A card is picked from 2 to 12. Okay. And the number on the card is noted. ठीक है. What is the probability that the noted number is either 7 or 8? Okay. Earlier also we were noting a number. So the end event is noting a number. Whether we are summing the two dice's result or we are picking a number out of these. Okay. So what we have to find out the probability that the noted number is either 7 or 8. ठीक है. So first, let's consider a scenario where heads has occurred. Okay. So we are going event wise. Okay. So first, let's say head has occurred. Then two dices are rolled. If two dices are rolled, so how many chances are there to get a sum of 7? So first let's discuss how many cases are there in which there will be a sum of 7. 1 plus 6, 2 plus 5, 3 plus 4 and 4 plus 3, 5 plus 2, 6 plus 1. So these are 7 favorable events. Otherwise, how many total possible events are there out of when two dices are rolled? 6 square, right? Out of 36 events, these are 1, 2, 3, 6 favorable events. When there is a sum of 7, or it is said na, or the sum is 8. 2 plus 6, sorry, 2 plus 6, 1 plus 7 cannot exist na. 3 plus 5, 4 plus 4, or 5 plus 3, or 6 plus 2, 1, 2, 3, 4, 5 events out of 36. Okay. So there we are reaching to our the last event, that is getting a 7 or 8. So this is the one place in which we can get, this is the one occurrence of event in which the sum can become 6, the sum can become 7 or 8. Or what if head comes? Okay, so let's discuss that scenario in the next page. Let's bring it to the next page. We have to select once again. Okay. What if head tail comes? So a number is noted, 7 or 8 it should be. And we are only choosing a number out of cards of from 2 to 11. So what is the probability of choosing a 7 number? This is also the probability of getting a 7. This is the probability of getting a 8. Okay. So probability of getting a 7 is ओके 10 बज गया यार, जल्दी जल्दी करता हूँ मैं. Probability of getting a 7 out of total 2 to how many cards were there? 2 to 12. So total 11 cards were there. 7 is only a number. Okay. Or probability of 8. How many card of 8 are there? 1. Total cards 11. Okay. So we have to find out the probability of this. So first, if event head is coming, so we'll have to multiply. So basically, if we are finding out the probability of getting a 7 or 8, so first probability of head, then probability of getting a 7 or 8 when head has come, divided by, sorry, not divided by, plus, this is also an independent event, probability of getting a tail, and then probability of getting a 7 or 8 when tail has come. So you will just do, and these were the probability of getting a 7 when head has come. Okay. And here when tail has come. Okay, nice. Probability of head is half. Probability of getting a, sorry, it's getting multiplied. Probability of getting a 7 is 6 by 36. Probability of getting a 8 when head has come is 5 by 30. I have summed them because there is a or. Probability of getting a tails is this. Probability of getting a 7 is when tails has occur is 1 by 11 plus 1 by 11. So this is how you can solve it, and the final answer will come out as 193 by 792. I have yes. So let me confirm it whether it is right or wrong. Yes, it is correct. Yes, it is correct. Okay. So make sure that you do a homework question. I'll send it in the WhatsApp group. Is there any doubt from this question?
No, sir. It's clear,
Okay,
sir.
thank you.